that's enough. Let's really get into this.
Well, what actually are subatomic particles? Subatomic particles are found in the atom. Three main types are protons, electrons, and neutrons. In an atom, negatively charged electrons move in an orbit around a nucleus of positive charge. In a similar way, the planets orbit around the sun. But unlike the solar system, electrons only move in certain orbits. Each orbit is called a quantized orbit, has a particular value of energy. When outside forces act on the atom will leap from one orbit to the other. Each downward leap will release energy as light. The light is released in minute bundles of energy called a quantum.
Scientists once believed that atoms behave like particles, but one experiment called the double-slit experiment proved that atoms behave like both particle and waves. Here's how it works.
Imagine you are throwing balls through slits to a wall. Where on the wall do you think most of the balls will land? Well, most of the balls will land directly in front of the slits. But if subatomic particles are thrown through the slits, something really fascinating happens. The balls create a striped pattern. But if a camera is placed in front of the slits, the atoms will land directly in front of the slits, the same pattern the balls created. When scientists saw this, they could only think of one thing: waves. If you constantly hit two balls in water, they both would create ripples. When both of the ripples combine, they create that same interference pattern. This is because in a wave there are crests and there are troughs. Imagine you are holding a rope. If you flick both ends upwards, it would create a bigger crest than if you flick one end alone. And the same thing happens if you flick it downwards. But if you flick one end of the rope upwards and one end downwards, it cancels each other. Heisenberg said that there is a wave of probability, meaning that you cannot predict with certainty the speed and position of a particle. The more you know the speed, the less you know the position, and vice versa. An atom can be in all these places. Only when it is measured, it takes a definite place.
The quantum world still baffles scientists today. I hope after this video you understand the quantum world a little better. My name is Anna and thank you for watching.